Welcome back to the second one. We are now looking at our basic player movement, and let's jump right on into Unity. So the character I'm going to be using for this one will be our little wizard girl here, and we've got some sprite sheets. And I've made sure that her pivot point is down by the feet. It should be 12 pixels in and 1 pixel up. And it's the same for all of the different sprite sheets. We will be using this one to start us off. That is number 7. So let's just go and find number 7 and drag it in. So there we have our player in the scene. There are different ways that we can get the player to move. Some people like to have it where when I push a button, it updates the position of the player. It works fine, but if you had any colliders which are very thin and the position caused it to jump from one side of that collider to the other side of the collider, you can actually move right through objects. So I don't like using that method. I prefer a method of physics where a force will be applied to her, and since the colliders are using physics as well, that force will be stopped when she hits a collider. So it will never go through an object. So let's start adding some components to her. We're going to need, I'm going to start with a box collider. And let's just shrink this down to be around her feet, because the only thing I care about her coming in contact with are other objects which would be on the ground. I don't care about overhanging branches hitting her head, just the ground. Okay, so we're finished with that guy. We're going to need an animator, which I'm going to be adding on some stuff to that later. We're going to need our rigid body 2D. And this is going to be a top-down game, which means there's no gravity. We don't have any jumping or anything going on like in a platformer. And if she hits something, normally she'll go into a spin. I'll turn on freeze rotation so that we get no spin there. And lastly, we can add our player script, which we set up earlier. Okay, so this is the basics of what we need for our player setup. All those nice animation frames, we'll get to that when we get to the module on animation. For now, let's go into the player script. So I'll open this in Visual Studio. And we don't need anything in start, and we're going to be using update. The first thing I want to set up is that okay, right. First thing we're going to set up is that this is the only player script that will be in any scene. And we'll need to access this player script from other scripts. So why not just set it as an instance of itself? Right now, once I set as static, that means that this will be saved into memory and we can access from anywhere. And we've set up a variable called instance, and we've told it that it's going to be of a type of player, but it doesn't have anything in it yet. So once I do this, instance equals this, now this script, the one that's on the player, the actual script on the player, becomes the instance. That's why we use this method here. On our update, actually, let's put in all variables we will need. I'm going to need a public float. I'm doing everything as public right now. You can set them to serialized fields later. Public float, and this is our player speed. And usually I find about 5 is good. Public, what do I want? Rigid body 2D, RB. We're going to need public. I'm going to need an animator later. So might as well do it now. Anim. I'll need a vector 2 direction. That's going to be the direction our player is going to be moving in. And I think that's about all we need for now. So right now we're going to go and find out what inputs are being delivered. So I'll say go hardest equals input dot get axis raw horizontal. That's our horizontal motion. And now we need our vertical motion. So this takes in our inputs from either the keyboard on the arrow keys, WSD, or the controller. Now we need to convert this into our direction. And we're going to create a vector 2 using the horizontal and the vertical. And our horizontal and vertical inputs, if you're pushing right or up, you get a 1. If you're not pushing anything, you get a 0. If you're pushing left or down, you get a -1. So that's going to create our vector for us, but we want them to move at player speed 5, which means we take all of that vector and we multiply it by our player speed. Oops, up there. Player speed. Okay. This is going to cause a problem, however, which I'll show you, and then we'll fix it. So we'll go back to, Unity. And let's attach the rigid body to the player script now. Just wait for the script to compile. It's taking its time compiling. Okay, there we go. You can do it. I've not rebooted my computer since my last stream, so it's a little slow. Come on. There we go. Okay, so I'm going to link the rigid body into here. I'm going to link the animator into here. I've got my player speed of 5. Now let's take a look at our motion. Let me play. And we have no motion. Why do we have no motion? Player speed is 5. We have no errors. So why do we not have motion? Oh, yes, of course. Very simple of me. All right, let's go back to Visual Studio. We've given a direction. Sure, great. But we never actually applied that direction to physics. So RB dot velocity is equal to our direction. I'm doing this in Fix Update because from everything I've seen so far in other tutorials, it's always said that this works better with anything to do with physics, and RB is physics. So I'm going to put that in there. And now we can go back to, oh, I keep hitting intro. I can go back to Unity and wait for it to compile again. And hit play. Okay, so if we watch our character, we've got motion left, right, up, down. But if I hit diagonal, the speed is more than left and right. And the reason for that is a little mathematics and geometry. Let's bring back up Leonardo. And got this drawn out here. So it's one up and one right. And if I combine it, I get this vector going up. And if you know Pythagoras theorem of a squared plus b squared equals c squared, that is longer than 1. So that's why we're taking that longer vector and applying that to our 5 speed, we'll get more than 5. If we're using something like a circle here with a radius, we'll get 1. But it's not doing that. It's making a product of the 1 plus 1. So we need somehow to pull that back down into being 1. And we can do that piece of code here placed on the direction. So if this is where we combine it to give our vector, then I'm going to take the vector and put on something called normalized. That will keep the horizontal at 1, the vertical at 1, and the combination of them as 1. And then after we do that, we apply the player speed. Save that. And we can give it a test and see how it works. Click for the file. And let's just put this up at maximum. Okay, so now that all of these are the same speed. Perfect. So that wraps up our player movement. One of the things I'm usually asked by my students is how to get the camera to follow. Very plainly, you just take the main camera and parent it to that object. But if you want to make something look nice, let's take the camera off. Okay, if you want something to look nice, in Window, I'm going to go to the package manager. This is not showing up on the screen, so let me just see if I can get, I think if I did this in OBS, where's my, no, there it is. There we go. Okay, so if I'm going to go and do this, I want to use registry. We come down, and there's something called Cinema Machine. Install. This package has a lot of uses to it that we're barely going to scratch the surface on what we can do with it right now, but this one will allow us to have the camera follow, but it'll be a smooth transition with how the camera follows, in that we can have areas where when the player is walking in the middle of the screen, the camera doesn't move, but as soon as it gets to a certain area, it starts to move. So I'm just filling time while this installs. Okay. And in order to use it, I'm going to right click. Cinema Machine now shows up here, and I want a 2D camera. I'll just leave it as that. And the camera needs to know right here, follow, who to follow. Excuse me. And that is Saffron. Follow. But now if I hit play, oh, well, when I hit play, it's full screen and it's just a blue background. We'll never know. I'm just going to click on the focused, pause, and unpause. Okay, so if we watch here where the camera is, and I start to move my character around, you get a nice transition of the camera following the player. So that's the last part of player movement. We have a character that moves, and we've added a camera that moves with the player. Thank you, and I will see you in the next one.